also need someone to come and help me with the.
Okay, I just had to get a microphone on so I could come over and give you a hand. Hold on here. I got to make sure mine's set the right height. Okay.
Okay, let me tell you what these devices are here. This is a Tesla coil with an output on it. This is a dielectric testing machine that we see here. And what we're basically going to do in electronic gadgets like capacitors and resistors and all this and that, they have their own characteristics. In this particular case here, a capacitor is a blocking device. I don't know whether you're fully aware of that or not, but when something goes into one side of a capacitor, it does not pass through that capacitor at all. What does pass through there is the reflection of it, which is from the ambient energy background caused by the Casimir and van der Waals forces. So what I'm going to do is put 8,000 volts on this plate here and let the fellow with the earth ground over there play with the other side. So with that in mind, let's see if I can turn it on here. Okay, I think they're on there right now. Okay, we've got 8,000 volts here, and you should be seeing sparking up there, very noticeable.
Right toward the middle.
And okay, when this is sparking, what's happening on the other side? Move it away from it as much as you can.
Just hold it close enough to keep it going all the time.
None of the energy from the side that I'm on is passing through the other side. The other side is reflecting the ambient background energy, which some people call 0 point energy or whatever. But you can see that 8,000 volts is putting up quite a fuss on the other side. And we have a sheet of plastic between the two plates here so that none of the energy from the side that I'm on can go through the other side. And if you don't believe in ambient background energy, which some people call 0 point energy, but I consider that an albatross. Ambient background energy is a much better term.
Many of you are familiar with the fact that AC sine wave passes through capacitance plates like this, but what about a DC? DC voltage doesn't pass through the capacitor. In this case, what you're looking at, if we were using pulse DC, you can excite a field on the opposite side with very little, and just like Tesla did, put a load on the opposite side, and it doesn't make a difference which way the anode or cathode is. On this particular, you can set it up so that if you're putting a pulse DC signal into it, you can extract a pulse DC signal out and put a load between the ground and your anode or cathode, whichever you've chosen to use. Now, if you buy the regular like Mallory or one of the other DC capacitors, those are very anode cathode specific. You have to be careful which one you use. But right now, using the Casimir effect, that's basically how all capacitors work. Is Casimir, he did some excellent work in defining. It wasn't that he was the first one, but he did some excellent work on defining what it is, and they call it the Casimir effect now. This is not a closed circuit to ground. The power source to run the exciter is actually coming from the little light-off pack in the back there. We are using earth ground through the grid house system here because they, at one building over, have a 1-inch diameter, 8-foot nice copper ground stake driven in, so that there's no way you can see that as developing a closed loop system. On DC, you can actually put a load. You can dike this white wire and put in a load. We've had a situation where we've had a 180-volt DC motor, 3 horsepower, with 26 milliamps exciting, spinning, no load, but it did spin at full 3450 RPM.
Okay, the commercial version of this is already being used to power electric airplanes and scooters and all sorts of things.
Okay, we're going to open up for questions. At this time, okay.
Is that strictly hooked up to the battery?
The power source to run it is coming from the battery, yes, the light-up pack. So it's not coming from grid. There's no closed loop there. And that was done specifically to ensure and demonstrate that there was no closed loop. Okay, first question.